In this video, I'm going to use the limit definition for the derivative to find the derivative of a simple radical function, like the square root of x minus 1. And part of the goal is to show that I'm using the limit definition. So I'm going to start by writing out the notation f prime of x, and then the limit as h goes to 0 of f plus h in this case is the square root of x plus h minus 1 minus the square root of x minus 1 is, subtracting the original function, and all of that is divided by h. So there's a key step that comes next. I want to multiply this by something that will simplify the numerator. And it turns out the thing that works is to multiply by the square root of x plus h minus 1 plus the square root of x minus 1 divided by that same thing, the square root of x plus h minus 1 plus the square root of x minus 1. Now this works because I have the same expression on the top and the bottom of this fraction, so this really just equals 1. And the second reason why this works, I can describe up above here. If I multiply a plus b times a minus b, I get a times a, which is a squared. I get a times negative b, so negative ab. I get a times positive b, or maybe I should write b times positive a from these two terms, and finally b times negative b, which is negative b squared. And because these two terms are exactly opposite, they cancel out, and these two terms are perfect squares, and so those perfect squares will cancel out the square root, which is kind of an essential part of our function. So let's do that multiplication in this case. So I'm going to get the limit as h goes to 0. My first term is going to be the square root of x plus h minus 1 times itself. So the square root of x plus h minus 1 squared. And that comes from these two terms being multiplied together. Next, I'm going to multiply these two terms, which gives me positive the square root of x plus h minus 1 times the square root of x minus 1. And now I'll take these two terms multiplied together, which gives me negative the square root of x minus 1 times the square root of x plus h minus 1. And last up, these two terms multiplied together, which gives us negative square root of x minus 1 squared, because one of them is a positive square root of x minus 1, the other is a negative square root of x minus 1. All of that is over kind of this messy thing. I have h times the square root of x plus h minus 1 plus the square root of x minus 1. But we're going to see in a moment a lot of things cancel. So these two terms are exactly opposite each other, and so they cancel each other out, and the squares cancel out the square roots. And so in the next line I can write a much simpler expression. The limit as h goes to 0, I haven't taken the limit yet. Here I get x plus h minus 1, and then minus, from the other end, minus x minus 1. All of that divided by h times the square root of x plus h minus 1 plus the square root of x minus 1. So, next up, I can simplify the top. This becomes a negative x and a plus 1, which cancels with the positive x and the minus 1 on the other side. And so the numerator can be written as just h. Again, I haven't quite taken the limit yet, so I have the limit as h goes to 0 of h over h. Oh, I should close this parenthesis. H over h times the square root of x plus h minus 1 minus, or no, sorry, plus the square root of x minus 1. Now we can clearly see that the h's are common factors in the numerator and denominator, and they cancel each other out. And so I can write this as the limit as h goes to 0, I haven't taken the limit yet, of 1 divided by the square root of x plus h minus 1 plus the square root of x minus 1. And so there's still an h in the denominator, but it's added to other things. And so if we send this h to 0, it doesn't make the entire denominator disappear. And so at this point I can evaluate the limit. And so I can write the expression without the limit notation as 1 over the square root of x minus 1, because that h became 0, plus the square root of x minus 1. Or more simply, this is just 1 over 2 times the square root of x minus 1. And so that is a nice kind of simplified expression for the derivative. My original function was the square root of x minus 1. Using the limit definition of the derivative, we ended up with 1 over 2 times the square root of x minus 1. I hope you enjoyed the video. Thanks for watching.